Okay, I wanted to do something a little bit different. I think the presentations so far have been on such fundamental material that you haven't been able to have a lot of creative freedom and fun with it, but I just wanted to show, like, we've all read the chapter, so maybe we can lean towards applications of what is in the chapter. So the chapter showcases these 1, 2, 3, 4, 5, 6, 7 big players in control flow. And I figured what better way to step through these than using our beer data set. So I'm focusing on just one of the 4 files. I think it's a beer states. If you go into the data folder, it's just got 4 columns in it. There's the state, year, number of barrels produced, and then the type of beer. So on premise, bottles or cans, kegs or barrels. Cool?
Okay.
So if and if else. If statements, you have if condition true. So I wanted to see if I take a random sample from the data frame, a random sample of the state, is it equal to, if it's equal to Nevada, which is where I live, then print my home state. And as you see here, there's no output. That's because we have if condition true, and it's not true in this case. So that's where if else comes in. So if condition true, else false. So now we get this more informative message in the console that sample was not from my home state, from Nevada. So in terms of giving yourself little breadcrumbs for did your code run, better to use if else in some situations or just if conditions. Lastly, R has a compact if else, which in a single function, you can put your condition and then comma true, comma false. And then I pose this question to the group: why is this if else printing not my home twice? My mental model is, what the hell is happening here? I didn't know.
I'm sorry, the second if else is in my mind one of the worst named things out there. It's the same as the other if, except it works on vectors.
Interesting.
So your sample here has
sample size 1.
Well, no,
Sample
it's
should be
still
size
sample size 1. Okay.
Yeah.
But isn't that the difference with if else, is it works on vectors?
Yeah. So we can parse that out or talk about that later if you want, or you want to play with that code. But I didn't know why that didn't work, because my mental model is, in this case, these two should be synonymous.
Wait, I think one is being printed and then the other one is the return value.
Ah, interesting. I'll buy that.
Because if else you can assign the answer to something, right?
Mm-hmm.
So I think that's what I.
So, but wait, why isn't that happening for
the first
the other
one?
Yeah.
If isn't a function, right? If is just control
flow.
Right, but like I don't think the if keyword returns a value. Well, I'm not sure, but.
Well, we can play with debugging if else.
Yeah, for sure.
Let's put a note and a pin in that. So I'm just going to build. So in the case where you have more than one if else, you can string together as many else if statements as you'd like. So here I've done a mutation where I'm turning that barrel column into a category, in a categorical column. So I don't know how many zeros I wrote. And now that this is recorded, I'll go down as stupid forever. But I think it's like 100 million, 10 million, a couple thousand, whatever it is. It's if the highest one, I want you, it's going to, if it's more than that or equal to that, you're producing a lot of barrels. Otherwise, it'll fall into the else if of many, and then a few, and then lastly, if each of those go to false, then you're producing not much beer. Does that make sense? Even though my explanation was choppy.
1 million, 10 million, and 100 million.
Thank you.
You can, I'm cheating because I'm looking at your case when and going up.
Yeah. So I wanted to contrast this one with case when, which to me aesthetically is a lot more readable and nicer on your eyes, where you have the condition tilde what you want to happen. So the left and right are giving you the same output that's on the bottom here, but instead of else, you set your last condition to true. And in a case when, it's important to note the order in which you set your conditions, because the first one that is captured as true is what it's going to result in. Okay, so that's case when. Does that make sense?
Yep.
Cool. All right. I could not think of an example for using Switch outside of a Shiny app, so I made a tiny little Shiny app here. I realize the font is small, but we're going to dig into this. Essentially, you have all our beer data sets, and then a select input that's just 4 strings, and we're going to switch the data set to, so if it's this materials string, we're actually pointing it to this brewing materials, the data set object. And then we'll print out a summary based on what we're switching. So if can you still see my screen here? Yeah, so thanks Tan for suggesting this presenter view. It's pretty cool, because now when I change this input, you see that it highlights on the side here what reactives are affected by changing this input. And just as I said, we're switching the input data set based on those strings. So that was my little example for Switch. And I also thought I could like plant the seed of exploring this data set using Shiny apps through the lens of Advanced R, but we can build a cool tool to start looking at to start exploring our data. Okay. And these Shiny apps are also going to be included with the notes. All right. So I was lazy with this example a little bit, but I essentially assigned these groups of states to regions based on Wikipedia, and in order to show a for loop, where a for loop you iterate through, here we're iterating through n rows of your data, and for each, we're going to assign this new column region is going to be equal to if the beer state is in region 1 or in region 2, in region 3. I was a little confused if I could use a case when inside a for loop. I haven't really done that before. I've just used case when in more of like a functional programming world. I also know that there's a ton of ways to do this better and cleaner, right? Like this would be a perfect case when. I just wanted to showcase a for loop, and also wanted to just pose to the group, I think when as I'm reading this book and like getting better at programming, I am forever shying away from for loops. I'm hard pressed I'm certain it exists, but I'm hard pressed to find a case where you can't use like an apply or something like that instead of a for loop, but it's a good thing to know about. I also want to, as an aside, I see there's a lot of comments. I get really excited and I can't see the comments right now. So you can like go ahead and just say, hey, Maya, and interrupt if you want to talk about that prior to me moving on. Otherwise, I'm just going to go through the comments rapid fire at the end. So yeah, so this was my horrible example of a for loop, but I figured that the majority of us are familiar with that. And then in the questions, I wanted to get into, here I'm using n row when it's kind of appropriate to use seek along. I don't think that's appropriate in this case. And then Hadley also highlights the importance of using the vector function. So we'll talk about that later. But here, just high level, here's a for loop. You're welcome. Moving on. I think my slides are stuck. Okay, I made another shiny app. So here's, this one is really contrived because I have never used a while loop. I understand the logic of it. I was hard pressed to find an example. And if anyone has a cool example, especially in the beer dataset realm, that'd be fun to just make a little toy app. But here, the while loop, essentially, while your condition is true, you're going to iterate through this loop until it's no longer true. So I made a drop down to pick the number of states you want to sum how many barrels of beer they've produced. And if you pick the number 5, it's going to alphabetically give you 5, 4, 3, 2, 1. And then if you pick 4, 3, 2, 1, right? There's way better ways to do this. I just wanted to highlight the logic here where we're setting I initially to 0, while the quantity, while I is less than or equal to this input, you're creating this numeric vector. So 5, 4, 3, 2, 1. And then I'm filtering here, the output is subset my states to the first 5 in this case. Does that make sense? Silence is golden, or maybe horrible.
That makes sense, but I would just never do that because you just do like input 5 and then you slice 5 and then you're
Oh
done.
yeah, it's a horrible solution. I just wanted to make, it's not the output that matters here. It's how we're programming and using this while loop. Yeah. And then just, again, to show you guys that this works, you see that this is changing contingent on that. Cool. Okay, then, so that was a while loop. Yeah, I mean, I kind of want to pose that to the group. If you have a scenario in which while like is actually makes sense as the tool you're going to use. I was kind of thinking of modeling, maybe in a sampling thing, you want to use while until you reach some maximum. I don't know. I don't do a lot of stat stuff.
I use it for when I'm scraping a web page on the internet or an API from the internet. Sometimes they do paging, so like they tell you like how many pages, how many rows they're returning, and then you have to offset by that many rows going forward to get the next set of data. So you pass like the next item in until you get to the end, but you don't know how many rows there are. So you do a while loop to do that just iteratively until you get to the end of whatever you're doing.
Oh, that's super cool. That's awesome. Thank you. Cool. Okay, and then my last thing here is we can harken back to the first example where we did the if my single sample is Nevada, print I live here, where we can use repeat. So we're going through this loop. I'm taking a single sample over and over again until I hit break, where this results into true. So essentially you read this as once we reach Nevada, print go grab a beer, and cut the loop, we're out. Otherwise, just print Maya doesn't live here. So you see, it took us, I don't know, like 17 times for me to be able to go grab a beer. Again, is this the most effective way of random sampling? No, but I just wanted to show the repeat logic. And again, Tan, do you have any, I'm picking on you because you last spoke, do you have any real world examples of using repeat? Is it also in the while category?
I find repeat, like, I think repeat kind of has this, like, I like separating the, like, what it's looking for logic from what it's doing logic. So while I use while, I've used a for when I can't figure out how to use a map or whatever. I don't think I've ever used a repeat.
Cool. I want to pose it to everyone else. If anyone has, speak now or forever hold your peace until.
So this is different than the REP function, right?
Yes.
Yes?
Yes.
Okay. I wasn't sure if they were synonymous or the same. Okay.
I just said yes because someone said yes, but I don't, what is that
Okay.
function?
See, that one I've used many times, but, you know, to repeat, you know, like a value some number of times rather than.
Oh, I see what you're saying. No, yeah. That's like repeat 1 5 times or, right? This is a logical statement. Repeat if true,
right.
Otherwise,
okay.
Stop repeating.
So it has to be used with an if then, or some sort of a
There's got to be.
conditional.
Yeah, that's my understanding of it. The book didn't even have an example. It was just kind of like an afterthought. There's also a repeat. So I don't want to make a blanket statement, but from the perfunctory research I did for this talk, they seem to have ifs in them.
Yeah, I think if you don't have a conditional, then either you break on the first time, which doesn't make any sense, or you have an infinite loop.
Right, that's what I was thinking. It's just going to go on forever.
Yeah.
Because you can do, like what you were saying, repeat 1 5 times. If you just do repeat 1, when's it going to break without some logic? So yeah, that's kind of the whole thing.
I think repeat you could actually use, let's say like you're uploading a file to the server, but you don't know if your server has internet or your internet's particularly crappy or whatever. If you run repeat until it uploads, and then you give it like some kind of statement like true when it's finished uploading. So you run a function until it uploads, and then if it doesn't, you do sys sleep 30 minutes and then try again endlessly until whatever. But it's not a particularly great way to do that because it also like locks your R session the whole time. So I wouldn't do it that way, but
so here's the use case, but don't do it.
It's stupid.
No, I like where your head's at. Cool. That's it. I just wanted to showcase some functions and also why, yes, I'm so glad you noticed. I put a logo on the slides because I'm fancy like that. So now I'm gonna see if I can open these questions here. I love case 1. Hell yeah, so do I. I have like just been turned on to them. I'm like, where have you been all my life? So there's just like a lot of ode to case 1 on here. What's a strict object checking mean? What is that in regards to?
So I was saying that I like case 1 a lot, except when I want it to return like a vector of, like, let's say I have like, I want do this if it's case A, do this set of like print out these set of tabs and then print out this other set if it's a different case. But if it's not the same length, like the vector isn't the same length, case 1 won't work because it's like it needs to be a vector of length 5 for both cases. Otherwise, case 1 will tell you that they're not the same length, so it won't work. That's really where that's at.
How are you getting the text highlighted in yellow in the Shiny app code? that is the badassery of, I put it on the slide here. If you do run app display mode equals showcase, it gives you both the app and the code. And I have never had a use case where my Shiny app is small enough that you can see all the code there beautiful. But like in a pedagogical, like teaching setting, like this one, it was perfect. I'm pretty excited about a use case for that. Okay. And then repeat is a while loop with a true condition. So I'm gonna circle back to that now. So I had some questions from the chapter myself, and I think they tie into some of the questions that people already asked. So I think this first one has a little bit to do with the strict object checking, because the book says switch is a compact special purpose equivalent to if. And it also says that you should really only use switch with character vectors. So I was wondering, like, what is meant by special purpose there? I guess, like, from a high level, if we want to start at the bottom of my thing here, what I've been pushing in the channel is I'm a very visual learner. So like, if you look at this schematic here, when I started drawing this up, I realized, like, I never made the connection that an if is basically the same as a for loop, but for is a loop. It'll do it again and again, whereas if, it just spits out when true. So I kind of wanted to see these high level patterns, and I didn't make one of these for switch, but like switch is kind of, would you say, I don't want to say it's redundant with if. I guess I'm trying to, like, on a high level, parse out when to use each of these.
Well, I think for a switch, the possibilities have to be disjoint and exhaustive, meaning that the condition you're testing can only be true in precisely one test of the switch.
Do you mean like it can't be a range of truths?
Well, so in a switch, there's like multiple tests, right? So do you have well, so it's let me go back to, it's a special purpose of the if, right? Because, okay, all right, let me see how I'm phrasing this. It means that you can convert it to a sequence of if-else statements, specifically of the form that's in the chapter. And that's because only one of the conditions is possibly true. So, like, so in the book, so I'm looking at this x equal A, else if x equal B, x equal C, etc. It's not possible for multiple of those conditions to be true.
Oh, so in the case of the Shiny app, it's always just going to be one of the select inputs.
Yes.
Okay, that makes sense. Awesome. Yay.
I wonder if it can evaluate things. I think switch also tests for equality, where, like, if you go x is less than b, you can't actually test for that in switch. Switch always tests for equality and not for inequality.
Interesting. I'd have to check, but I'll take your word for it.
So, like, if your if statement is like x is less than 5, switch doesn't know what to do with that unless you list out 1, 2, 3, 4, and 5.
Right. That makes sense. I'm happy with that. Okay, the book, my next question here is the book stresses this. So you have your three means, whatever, and then you create a vector with length means. Why is that better than just doing this? Does pre-allocating the length save you some computation?
So I think this goes back to something we talked about a couple of weeks ago, and I think the answer is yes. And the thing is, if you're changing the length of it every time, I think it's having to copy it and rewrite it every time. Whereas if you pre-allocate it once and then you're just, you know, mutating or changing the value as you stick it in there, I think.
Okay, so it's like, so one is a copy on modify and one is a copy in place?
I think so. Am
Potentially?
I right there, Tan?
I think that sounds right. I'm flipping to the book now. The one thing about not being the presenter is I can just look at that stuff. I think it's something like you pre-allocate the memory because otherwise you have to grow that object and then that changes the whole reference.
Cool.
Then there's another comment in the book about if it has length 0, that can create a problem. And somebody commented earlier about something failing when, you know, when the list is of length 0 or something, right? I think that's one of the other things related to it.
Cool.
I think that was actually in the for loop. You can't do sequence 1, 2. If your state is static, it makes sense. But if it's not, because you're like uploading a data set or something, or it's reading an API or something, if n row is equal to 0, it won't run the for loop.
Right.
Right.
It will error your app to crash.
That's good to know. All right. My next question was, the book warns against using length x, and that's, I think we just got to that with our length 0. But is there a time when you'd prefer length x over seek along, or should we always just be defaulting to seek along?
I'm going to admit that I've never heard of seek along before I encountered it in this chapter. I've always used length.
Me too. So that's why it seems like the tidy way. So I'm just going to keep using that now, and then if I break something because of it, I will have an answer. But so far, I can't think of any downsides to using seek along instead of length. Okay. So exercise 5331, and I can toggle to the book if you guys want. You create a loop here and it says, why does this work? And that's because loops can also count down as well as up, right? So you go from 1 to 0 in this case, but I guess I got confused with, because R doesn't count down to 0, since this loop is happening at 1, does it just stop at 0? Or do you get another, like, you don't get another NA, there's no list index 0 in R. Do you know what I'm saying? Like the first iteration, you're setting x to 1, it's equal to NA, and that's what's printed out here. And then the second loop iteration is just numeric 0, like that doesn't get a house anywhere. It just, evaluation stops there.
I don't think the evaluation stops, but that the assignment creates a different object. Right? Is that what I'm, because you're assigning to index 0.
Mm-hmm.
I mean, if you have a vector, I don't know what happens in a vector if you assign to index 0.
I guess that's like the bigger question that I'm asking here.
Yeah. Well, I can do it. Awesome. Well, nothing happens on mine.
So it's like
It doesn't change
silently
the vector.
happening.
It doesn't change the vector.
Interesting. So I guess now we know about what happens when you assign something to 0.
So that for loop. Yeah, I don't know.
We could play with that. Yeah. And then lastly, now that I've like introduced you to these functions, or you already knew. So the first thing is reading over these visuals. Is there anything that's glaringly incorrect? And for me, as I was drawing these, for and while shouldn't be exactly identical, or else there wouldn't be two different things for them. But I just couldn't think of a better way to draw them out. And I have a whiteboard if you want to wipe them.
I don't think for actually evaluates for a condition.
Interesting.
For, you pass it a sequence of vectors to tell it how many times you're doing it. While is the one that evaluates the condition. Is it still good to run the loop, or are we out?
Oh, okay.
For declares how many times it's going to do something and then does it, right? So for sequence along this means take this many rows, or take the length of this vector and do it this many times, and iterate over that. And then while is like, okay, so just keep doing this until it's done. And
Right. So for is not unlike, okay, I'm just trying to put words to what you're saying, make sure I get it. For, the condition is not a true false, it's a length of something. Whereas while you're taking a condition, and repeat is also based on a condition. Yeah.
Yeah.
That makes sense.
Repeat is almost like the opposite of a while, where like if the thing finally successfully runs, it does it once.
Yeah.
Otherwise, blank.
Right. The default behavior is the false. That's how I was reading it too. Cool. Okay. I think I can redraw this now.
Sorry.
Awesome.
What was the repeat versus while explanation?
So repeat tests a condition,
Mm-hmm.
and then if the condition is false, I think,
While test condition.
repeat does as well.
The programmer has to write the test inside the repeat.
So repeat, if the condition is false, it's gonna, repeat, if gets a condition, like a second layer is where the condition lives. And then when the condition is false, that's the default behavior, right? That's why we get all these Maya doesn't live here until that condition is true. So the true thing only happens once. I think that's what you were saying.
Oh, actually, it doesn't even need to have a condition at all.
Right.
As I see what Darren's saying. It just needs a break somewhere. Otherwise, you're repeating endlessly.
So what would a repeat be without an if statement?
Bad code. Well,
can you do like repeat a number for the, like within a vector and then break once that vector is a certain length? And then we're kind of going back to Scott's thing of like rewriting the rep function in like a crazy way.
Right.
Because I couldn't think of how are you going to break without a condition?
I mean, it's effectively an infinite loop without without a break, right?
That's why I was thinking repeat something, like repeat 5 for some vector, continually add 5 to it until that vector is 10 elements long. But you'd still have,
Yeah, you need some kind of condition to get out.
yeah.
Well,
So we're back to repeat needing a condition.
right, but the condition isn't, so in the while the condition, well, in the while you need at least one condition specifically at the top of the loop.
I see, whereas this is one layer.
This is inside the body of, yeah.
Like you can have a repeat and then it's an infinite loop without your condition inside it. But going back to this graphic, the condition is not inherent within the repeat. Like you don't do repeat your condition.
Okay. Well, I just thought of one difference. In a repeat, you enter into the loop at least once. In a while, you have to pass the condition the first time.
You could pass an if condition and then break right away before you evaluate the rest of it.
Sure. Yeah, I accept, but you know, I'm saying, but I would say that that's a line of code in the body of the loop.
Yeah.
Right. So in Shiny terms, because I always Shiny, it's the difference between an observe event and an observe. Is that? So like observe event, you declare what it's watching for, and then when that happens, you do a thing.
Yes.
In observe, it evaluates everything consistently, and then when anything changes, it runs. So it's kind of like that, where it looks at the whole loop, and then just continually does that.
I like that analogy. I still need to refer to post-its for observe event, reactive, and react value. But I like it. And I encourage you to go play with that and see the draw these high-level patterns. I think that's really fun. Cool. That was really helpful for me. I hope it was helpful for you all. That's kind of all I got.
Not to confuse things here, but for those of us who've written code in other languages, R does not have a explicit do while. Am I correct in that?
That is correct.
Okay. But repeat, and checking whatever condition you want with an if and exiting with break is kind of like a do while. Does that?
Yeah, I think if you squint, yeah.
Okay, I was just trying to think of.
Yeah. I would need to play with that more. I don't know if people who are coding in other languages can speak more to that comparison. Yes, not. All right. Can someone who's not presenting open up the repo? Do we have a presenter for next week? Do we need one?
Yeah, it's me. Is it functions?
Woo! Next week is functions.
Yes.
Very excited and have fun with it.
Why are you saying is it huge?
No, I mean, you don't have to relay the chapter, you can just do something fun, like with the beer data set or relay the chapter explicitly. I don't care. Do whatever you think is fun is literally what I'm saying. Have fun put the fun in functions.
It will be fun.
Awesome. Yeah, and then do not shake your head at me. Yeah, that's it. And then another thing that I threw in the Slack channel is that I'm kind of like reorganizing our question and answers into a Bookdown. If anyone's interested, I can give you a tour of that since we have a little bit of time. Or no, that's boring.
I'm interested.
Cool. Okay. Yay.
I love that color.
It's Windows 95.
Yes.
Okay. So I'm actually excited to talk about this because I don't know the best way to structure this folder. I'm very new to Bookdown, like today. So here in this Q&A folder, rather than have what we had before was one massive folder for all the questions and answers that we ask within this in our meetings, and as well as I've been like collating from the Slack channel because the format of Slack to find questions and answers is not great. And then I was thinking just for like async people out there who are watching this video but couldn't attend, you can answer questions or ask them there. So Bookdown's pretty cool. I created a project within, so this is within the book, within our, within the repo, there's another R project, and I'll show you why I did that in a second.
Wait, how'd you get the purple color in your ID?
Fairy Floss. It's from our.
I'm so jealous. It looks so good.
Why are you jealous? It's just a theme. I could link you. It's all generic. I'm gonna do it. So anyways, why I made this project is because you get this build book GUI button. I'm sure there's a command to actually build your book, but essentially we have all these shenanigans files that help us build the book, and then the index is just a little preface here, and then we're structuring our files. This is the meat and potatoes, chapter 2, and it's just Markdown with a CSS file, and then when you hit build book, you twiddle your thumbs for a second. Do. This is super fun. I love progress bars. Did it error out? Awesome. So that should have worked. Looks like I got a warning here. Oh.
I always mind my business when I get those warnings. I'm just like, that's between you and God. I don't need to be implicated.
No, I know what it is. Okay. So here's the Bookdown, where each of those markdowns, just by virtue of being called 1, 2, 3, 4, it's magic that they're stitched together in order. So now each chapter has its own markdown file, and you can visit that here. And then publishing a Bookdown to a website is also like magic. It's very, very easy. So this can live on a website eventually, but I just wanted to point everyone to this thing that we've been putting together. So yeah, feel free to contribute. Like, for instance, there's like little red boxes around the questions that have yet to be answered.
Wow.
Yeah, one R project inside of another one. So I think I did that in a later version. In the chat here, it says, does it bother you that, like, this should be a 2? I think I could change that.
Yeah, it just occurred to me that I was looking, I'm like, wait a minute, those don't all match the numbers. And I was just like, I wonder if you can just skip 1 and start with 2, because we didn't really start with chapter 1, right?
Exactly. I might name this like preface thing chapter 1 just to get our numbers in order. This isn't real yet. It's
I was just figuring it made sense to do earlier than later. That's why I asked.
Absolutely. This is still in like an experimental branch in the repo. I was just wondering if people like this format. I assume it's easier than 1 mega RMD file for all the chapters. Cool.
Yeah.
Awesome. And then, I don't know, I like some tangible thing that we've been working on this and meeting, and people have been asking such rad questions that I want to just collate that, and I'm sure other people in the world have those questions as well. So yeah, good job, team. I got nothing else. And I'll see you next week. Anyone else have any questions?
Can you make flashcards in R?
What does that mean? Like slides?
Yeah, that's literally it. Yeah, because I really like some of your diagrams. I want to be able to just put them in flashcard-like things, but you're right, that's just literally a slide.
There is actually a flashcards package.
Oh.
Of course there is. And I'm
That'll
sure
get
you can make them in the shape of hexes.
That's awesome.
I've been putting these visuals that we've been making in the book too, because I don't know, maybe I'm stupid. I think visual accompaniments is when I'm like, oh, this is all starting to...
No, that's literally, I just want to take all your visuals and put them in one place, because I think...
Well, they're yours too. They're just as much mine as they're yours.
Or we can make a cheat sheet at the end. I'm sure
That would be
that's not
awesome.
too complicated. Yeah.
Cool. Okay.
All right. Thank you.